Are you tired of not being able to understand anyone? Is the eerie, quiet landscape just not your feel? Want to make your head more fashionable? Hi, Matthew Albuck here with ears and the sense of hearing. Now you can hear everything your annoying little cousin yaps about. Using the structure of the ear, the sense of hearing can be implemented. Once installed, the organs that help with hearing can be found here, here, and here. That's right, as an added bonus, this also gives your brain another function. To help you understand how the ear and brain help you hear, I'm going to go through the whole process. This is a really complicated process. I'm going to say a lot of big words, so try to keep up. To help all of you who have no inkling about human anatomy, there will be a TLDR of the whole thing after I get done rambling. And to help you even more, I'm going to have pictures showing up on the side so I can point to things and tell you where they're at. The sense of hearing is performed in complicated ways, but here's the gist of it. The visible part of your ear is called the pinna. The pinna can be used to direct sound towards the ear canal. The ear canal also produces this stuff called earwax. It can be annoying at sometimes, but trust me, it has a purpose. Earwax can help protect the more inner parts of your ear and thus your sense of hearing. The ear canal then leads to the eardrum, which is the beginning of the middle ear. But before we move on from the outer ear, which is the area we just covered, we'll do a quick review after each area. So we have the pinna, which is the outer area, and the ear canal. This area is the most fun area in the ear because it's the only area to have bones. These bones are called the ossicles, and there are 3 of them. The ossicles are called the malleus, incus, and stapes, which are also called the hammer, anvil, and stirrup respectively. These bones are also the smallest in the body, the smallest of the 3 being the stapes. The stapes also transmit sound to the oval window. The oval window is a membrane that separates the middle ear and the inner ear. This is very important since your middle ear is air-filled, while the inner ear is fluid-filled. And there's another membrane there too. This one is called the round window, which displaces inner ear fluid as sound waves go through. The stapedius and tensor tympani muscles also help protect the inner ear with a stiffening reflex. And now we can begin describing the inner ear. This is a very complex area, so try to stick with me. The inner ear contains the cochlea, which is a spiral-shaped tube. It is also fluid-filled. The cochlea is divided lengthwise by the organ of Corti. This organ is the main organ of mechanical to neural transduction. Inside the organ of Corti is the basilar membrane. This membrane vibrates when waves from the middle ear move through the cochlear fluid, also known as the endolymph. It's also tonotopic, which is, and I quote, a spatial arrangement of where sounds of different frequency are processed in the brain? Seriously, guys, what does that even mean? This makes every frequency have a place of resonance along with it. Motion in the organ of Corti also make hair cells depolarize, which are specialized auditory receptors in the organ of Corti. Before we move on talking about how the ear works, I'm going to explain to you about how a nerve and a synapse work. Because this is the most complicated area in the part of the ear, because this is the area where it transfers information from the ear to the auditory nerve. So just to be clear, a synapse is an area between neurons where information is transferred from one neuron to another neuron or cell. In order to do that, the axon terminals produce neurotransmitters that go to the other neurons, dendrites, or the cell. And if that didn't really help you, here's what the picture looks like, and trust me, it's a bit more confusing than everything I just said. The hair cells produce neurotransmitters at synapses with fibers of the auditory nerve, although they do not produce action potentials. The auditory nerve itself can produce action potentials. So, just to recap, the hair cells cannot produce action potentials, but the auditory nerve can. In this way, the patterns of oscillations on the basilar membrane are converted to spatiotemporal patterns of firings which transmit information about the sound to the brainstem. Yeah, I can't help you with that one. Oscillations are usually seen as a rotating, like Yeah, it's like it rotates, and it's a pattern of a rotation, and it's the pattern of the rotating vibrations on the basilar membrane that are converted to whatever spatiotemporal patterns are. Yeah. And after all that, we're done with the ear. But before we move on to the brain, I would like to go through the heavily simplified version of what I just said. The outer ear is made up of the pinna and ear canal. The outer ear funnels sound like a reverse megaphone. The middle ear contains the eardrum and the ossicles. The eardrum sits at the end of your ear canal, and the ossicles carry vibrations to your inner ear. The inner ear contains the cochlea, which contain hair cells. When sound reaches the hair cells, it transmits information to the auditory nerve. Putting all together, we get this process. Sound travels through the ear canal to the eardrum and causes it to vibrate. Those vibrations then travel through the eardrum, to the ossicles, and then the cochlea. The hair cells inside the cochlea vibrate and send information to the auditory nerve, which sends it to the brain. Now, that's that much. But we still have to go through the brain. And guess what? There's even more big words. The way the brain works with hearing is as follows. Sound information from the cochlea travels through the auditory nerve to the cochlear nucleus and the brainstem. Signals are then sent to the inferior colliculus and the midbrain tectum. The inferior colliculus has an auditory input with limited input from other parts of the brain. Basically, that's a fancy way of saying it makes information about the sound using other information about your surroundings. So, for example, if I you say, here, drop this water bottle, I'll hear that sound, and using other senses, I can tell that the water bottle was dropped. The inferior colliculus is also part of the reason we have subconscious reflex, such as the auditory startle response. The medial geniculate nucleus is part of the thalamus, where sound information is projected to the primary auditory cortex, which is in the temporal lobe. And the last and final part we need to talk about is Wernicke's area. It is named after Wernicke, and he will be greatly missed. This area interprets sounds and tries to match them up with certain things, and is especially helpful in understanding spoken words and language. So all you that have ears and are listening to this infomercial again, thank Wernicke. Now, that's it. That's the entire ear and how the brain processes sounds and helps you hear. But now that I'm done talking about that, we get to talk about some flaws. That's right, we're so sure you'll like our product, we're even willing to tell you some flaws. Disturbances at any level of the ear can cause hearing problems, which can also include auditory hallucinations and problems with perceiving sound. This is especially prominent with bilateral disturbances, which means it affects both sides equally. There is also a problem with hearing loss. There are 5 main degrees of hearing loss: mild, moderate, severe, profound, and complete hearing loss. Causes of hearing loss can affect anywhere in the ear and even in the brain. The causes for hearing loss are as follows. Heredity from your parents. Congenital conditions, which is a medical condition that occurs before or at birth. Presbycusis? Presbycusis? Is that how I say it? Anyway, it's just a gradual loss of hearing in both ears. This mainly just happens while you age, with your ear degenerating during the process. Some people even call this word age-related hearing loss. And finally, we have acquired hearing loss, which means sometimes it's entirely your fault. You can cause acquired hearing loss by listening to very loud noises, getting an infection, or ingesting ototoxic drugs and chemicals. From what I read, it was just chemotherapy drugs. It could be more, but that's as much as I know. If you are in a situation where this is a problem, don't worry, your ears are durable to an extent. But don't try to find that limit. Although we can help install this product, we can't really fix it. But we can help prevent it, the noise-based hearing loss at least. You can insulate a room to absorb sound and it won't be as big of a problem, but that's a lot of work and who knows how big your room is. You could alternatively use earplugs, which fit in your ear, or earmuffs to reduce sound from getting to the ear canal. While those products help prevent hearing loss, we also have products to help people with hearing loss already. As I said before, we can't really replace your hearing if you break it, but we can help it work better. With the help of hearing aids, you can hear a little better. This works in a way like this. Sound is measured in a unit called decibels. People without hearing loss can hear almost anything at any decibel level, but the safe level for hearing is at 70 decibels or lower. With hearing loss, it gets harder to hear because your ear begins to become not as receptive as before, either with age or degeneration. This means sounds at lower decibels can barely be heard or not heard at all. People with mild hearing loss can hear quiet sounds between 25 and 40 decibels, while people with moderate hearing loss hear them before 40 and 70. People with severe hearing loss hear them before 70 and 95 decibels, and people with profound hearing loss hear them with 95 decibels or more. This is where the hearing aid comes in. Your hearing aid takes in sound and amplifies it to make it louder for the person with hearing loss. So although you can't hear something at 40 decibels, your hearing aid can make it louder so you can hear it. You can also get another sort of hearing aid called a cochlear implant. This is a type of hearing aid that also helps with hearing loss in the brain. Now, there is one condition of hearing loss that is irreversible. This level of hearing loss means that you cannot hear at all, which we call deafness. Most of the time when someone refers to you as deaf, it means you can't hear at all. But deafness is an area between profound hearing loss and complete hearing loss. Another method of prevention is called a hearing test. Whether you care about your hearing or not, you have to get a hearing test every once in a while. This is nice because the hearing test checks on how well you can hear. An odometer is used for this. This allows your doctor to measure your hearing threshold at different frequencies. This can help detect onset hearing loss, although the odometer is a machine and also has its problems too. That's about it for the solutions to the problem with our product. But I've also heard that we have competitors trying to sell their own sense. So let me give my understanding about their connection with ears and hearing. For sight, understand that hearing helps with identifying what made a sound. While your sense is the one that hearing has little to do with, hearing can help you hear a sound that an object made and help you look at it. For taste, your tongue has the ability to make words and communicate with others. But if you can't hear, your brain doesn't learn how to speak. Just find a deaf person because they have no idea how to form words. For smell, your nose actually helps me more than I help you. You see, there are these things called eustachian tubes. Using the nose, the eustachian tubes help stabilize air pressure in the ear, so that it doesn't rupture and bad things don't happen. That's why if you can prove you have a nose, you can get a eustachian tube for free per ear. We aren't trying to make you break your product either. That's why if you called right now, we'll give you earplugs or earmuffs for an extra $2.99. Your choice. And the final deal, which is very good in my opinion, is if you text us right now, we'll send you an extra ear for an extra $19.99. Want to get out and hear the birds sing? Want to hear the noises of the city? Want to hear that divorce court show at 3 a.m.? Call the day, and the power of the ear, hearing, can be yours. We only accept US dollars, nothing else. Screw you, Europe.